Now let's take this to the next level. What if we have a rational exponent that has a number on top and a number on the bottom? Like, let's say that we have 8s. Oh, that's a funny 8 to the 2/3 power. What does that mean? Well, we still have the 2 here. So the 2 is going to go with the 8. The denominator, we are still taking that root. So we're doing the cubed root of 8 squared, which is going to be the cubed root of 64. And that, I believe, is 4. So that's how you evaluate those. So now let's work on writing these with rational exponents. So anything that why the base is being taken to a power to, that's going to be in the numerator. The root that we're taking it to is going to be in the denominator. So this is going to be y to the 3/2. What if the exponent's on the outside? It doesn't matter. Order of operations doesn't say anything about which exponent we have to take first. So it's perfectly fine. Our base, the whole thing is inside the root. So our base is 2x. We're taking it to the 4th power, but we're taking the 3rd root. So it's 2x to the 4/3. We have 3a over 4b to the 3rd, but we're taking the square root of it. So that's 3a over 4b to the 3/2, because it's taken to the 3rd power, but the root is half. The root always has to go in the denominator. So go ahead and work on problem 43. But first, let's take a look at problem 44. I can save you a couple clicks with videos this way. So let's take a look at these. Now, as a reminder, it's the dates up here, and highlight this if you need to. A to the negative n is 1 over a to the n. Do not change these into negative numbers. It is 1 over whatever number is shown. So just keep that in mind. So 125 to the 2/3. So we are going to be taking 125, we're squaring it, and then we're taking the cubed root. Let's see what happens when we do that. I just want to see if this can be simplified. So 125 squared. Then we can take that number to the 1/3. And we get 25. So that's pretty cool. So we can evaluate that completely. How about 16 to the negative 3/2? It's the negative 3/2, so it's going to go in the denominator. I'm going to try it this way this time. I'm going to take the square root and cube it. Like I said before, it doesn't matter if the cube goes inside the square root or outside. It is still going to end up being the same number. Square root of 16 is 4. 4 cubed. Let's see what 4 cubed is. 64. So this one is going to be 1 over 64. 32 to the negative 2/5. Again, a negative sign in the exponent. We're going to go 1 over. Let's see here. How do we want to do this? Let's take the fifth root first. And then square it. It's easier to square a smaller number. So let's see what the fifth root of 32 is. Take our calculator. 32, our x to the y button, in parentheses, 1/5. That is 2. 1/2 squared, which is 1/4. So look at these trickier guys. So this negative is on the outside. So this answer is going to be negative. We're not taking the root of a negative number. We are just saying it's negative whatever the square root of 25 cubed is. I'm going to take the square root of 25 and then cube it. So that's going to be negative 5 cubed. I think that's 625, but I'm going to double check. Nope, I'm glad I checked. It's 125. I think if you do it another time, it's going to be 625. It's 5 to the 4th. Anywho, so this is another one. The negative is on the outside, so your answer is going to be negative. But your exponent is also negative, so it's going to be 1 over that negative number. So negative 1 over, same thing, square root of 25 cubed, which we determined is negative 125. It's just, we're taking the reciprocal. It's the exact same problem. It's just a negative exponent this time. How about negative 25 to the 3/2? So we have the square root of negative 25 cubed. That's a problem. We can't take the square root of a negative number. So this guy does not exist, because we're only talking about real numbers in this course. The number here would be imaginary. So work on your last student-led examples, and I wish you the best of luck on the upcoming exam.